Good morning, boys and girls. I hope that you're enjoying your long weekend. It's Miss Bulke here, and I am going to be teaching you today the wonderful world of Pythagorean theorem. So, from the proof video that you had just watched, we have an understanding that of how to get the formula in order to find some missing side lengths of a right angle triangle. So, when we have a right angle triangle, there's a few things that you need to know first. Whenever we have the right angle, we have two sides that are adjacent that we would call sides A and B. The side across from any right angle triangle is always known as C, and it is the hypotenuse. So whenever you're dealing with unknown side lengths and you need to find out what they are, it's the best way to do is first of all trying to figure out where the hypotenuse is. So then after that, we figured out this. We know that if we are adding side length A and we square it, oops, cut off a bit there, and then we add side length B and we square that, we are going to end up with the side length, the hypotenuse C squared. Okay, so one of our side lengths adjacent to the right angle, square that, plus the B side length squared is always going to be, after we add those up, the side length of the hypotenuse squared. So we can use that formula in order to find unknown lengths. So if we end up having a triangle that looks like this, and we have some unknown numbers and whatnot, we are able to find out this by actually putting this, a triangle like this, we could actually cut this down the middle. And then if we do that, we end up having two squares. Okay, so we actually have two right angle triangles. So if we're ever in a situation where we need this, we are to find out some unknown numbers, we would be able to find out the height in this, because that would be our, say, our B squared. We would have our two adjacent side lengths unknowns, which would be our A squared. And across from the right angle triangle would be our hypotenuse. So, oh, sorry, they shouldn't be squared. It's just A, B, and C. So in order to find the unknowns, we could put them into our formula, A squared plus B squared equals C squared, in order to find out these unknowns. So now let's put that into use. So I have given you a triangle here that has two adjacent sides from the right angle triangle. So this would be our 3.2 would be, say, one of say our A side. 4.6 would be another side, and across from the right angle triangle is our C. So if we plug these into our formula, so we use our formula because we are trying to find out what our hypotenuse is in this case. So we know the formula for this is if we square one of the sides, we add it to the square of the other side, we are then able to find what C squared is. So all we're doing right now is using this formula to try to find that out. So because my unknown is a C, that is actually the C squared is what I'm going to be looking for. So I rearrange my formula first to find my unknown. I find it easier putting it on the left side. A lot of you do, so I'm just going to use that for right now. So C squared is equal to A squared plus B squared. So I just rearrange this because now all I'm going to do is start plugging in my numbers. So now I know I have my unknown C squared is equal to, if I take one of the sides, so A, which is 3.2, and I square that, then I take my B side, which is 4.6, and I square that, I'm going to be able to add them and end up with C squared. So let's just start to solve this. So 3.2 squared would be 10.24. You can also stop it now and try it yourself, and then you're going to be able to see if you got the right number at the end. So 4.6 squared would end up being 21.16. And then after that, if I add them together, I end up with c squared is equal to 31.24. Now, in reality, if we think about this, 31.24 is very long, and that doesn't make very much sense for it to be the hypotenuse of a triangle that has a side length of 3.2 and 4.6. So what we need to do here is we're just trying to find out what c is. Here we have c squared. So in order for us to get rid of the c squared, or just to find out what c is, because it's a squared, it means this number times itself is going to equal that. So whenever you're dealing with a number times itself, we're finding out what the square root is. So the square root of 31.24 is going to give us what c is. So therefore I solve that in my calculator and I end up with 5.6. So 5.6 times 5.6 should end up to be 31.24. And now I think logically, if this is what my c is, 5.6, does that make sense? Yes, it does, because that makes sense that I have a 5.6 it would be a little bit longer than my two adjacent sides, but not 31.24. So that would be a situation of how to find out a missing hypotenuse. So now let's take another one, because this time I'm going to give you a triangle that is a little bit different. So this, it's going to be the same. It's still going to be a right angle triangle. Let's turn it this way now, so we can see it's going to be the same thing. And this time, my right angle triangle, so my hypotenuse is across from it. So this would be my C, and then we have my A and my B. But this time I am going to be giving you two knowns. So my known is my hypotenuse, which is 8.2, and I'm going to give you one of the side lengths adjacent to the right angle, which we'll call 6.2. So if we're looking at this, first of all, we're trying to find out what side length, say let's call it B for bulky. All right, so we have side length A and B, and we know that our C is our hypotenuse. So let's figure out by using our formula. So I start with my formula, a squared plus b squared equals c squared. Now, in this case, we are trying to find out what b is, the unknown b. So I'm going to take my b squared and I'm going to isolate that. So I'm going to rearrange the formula first before I start plugging things in. So b squared, the b is what we want to know. So I'm isolating that. I'm going to keep my c squared how it is, and I'm going to move my a squared over here. So I'm adding on this side, I subtract a squared on this side. Or to get rid of the a, I have to subtract an a square. So whatever I do on one side, I need to do on the other side. So this is our algebra here, just rearranging the formula first. After we've rearranged it, then we can start plugging in our numbers. So we know our b squared is our unknown that we do not know. Our c squared would be across from the right angle triangle. So our c squared is our hypotenuse. So this would be 8.2 is our c length, and we're going to square that. Then we're going to subtract our side length a, so that's 6.2, and then we're going to square that. So once we solve for this, we now have b squared equals 8.2 squared would be 67.24, and I'm going to subtract 6.2 squared, which would be 38.44. Okay, so then after that, we subtract the 2 and we would get our b squared. So our b squared would end up to be 28.8. Now, we only want the b length, the side length. So the side length is not squared. We just want to find b. So, and also if we look, 28.8 would not make sense here. It would be far too long. So it would come off the side and it wouldn't make a right angle triangle. So for here, we need to find just b. So we need to find the square root of 28.8. And once we solve for that, we would end up with 5.366, but we are going to round that to 5.37. And that would be 5.37 units. And in this case, we're just using units. If it was centimeters, we'd use centimeters. But in this case, our answer, so B, would be 5.37. All right, so there is a quick lesson on Pythagorean theorem, and we're going to be applying this concept in many equations in class. All right, have a rest of the good weekend.